You're watching CTOM TV. Knowledge is power.
What are some alternatives to chemotherapy that work?
Well, I think there's many alternatives to chemotherapy. I think targeted therapies, for example, and immunotherapies, and of course surgery and radiation.
Okay.
Proton therapy is another alternative.
Ooh. Okay, so let's just take a moment. I'm just making a quick note here. Let's just take a moment to briefly discuss each one of those, because you're an expert, you know what that means, but a lot of people at home have really only heard of chemotherapy,
Right.
or that, chemo and radiation. That's what we hear so much, because for so many years, that's all that there was.
Mm-hmm.
But in the last 10 years, there's just been this huge influx of new different ways.
Yes.
So let's start with a brief explanation of what a targeted therapy is.
So targeted therapy targets a particular mutation that is found through tumor DNA sequencing,
Okay.
Or it could be an inherited inherited mutation such as BRCA, which is also detected through sequencing.
Okay.
And it targets the molecular features or mechanisms of that specific mutation and how it affects the cancers.
Okay, so targeted therapy. So we need to know the gene,
Yes.
right?
Yes.
One of the things we talk about a lot in this show and just in life in general with our clients and doctors is the importance of genetic testing.
Mm-hmm.
So this treatment here that can directly target those mutations, you have to have had some sort of genetic testing to know what mutation you're targeting.
Yes.
But then when you have that, you can just go straight for those bits of that cell. And let's talk a little bit about how that, before we get to the others, is so much more beneficial than chemotherapy.
Right.
Could we say,
Well,
why?
For starters, it actually targets the molecular features that are unique to that cell type, and that's going to be very unique in every person.
Okay.
And so it's going to have more efficiency and less side effects.
Okay. So that's the key there, is these targeted therapies are only targeting those bits of those cells with those mutations and not all of the rapidly reproducing cells in your body, which is what chemotherapies do.
Yes, correct.
Mm-hmm. Yeah. Okay, so immunotherapy. What's that?
Immunotherapy, yes. There's lots of developments in immunotherapy lately. Probably the biggest development has been in PD-1 and PD-1 ligand inhibitors.
But what exactly is immunotherapy before we talk about the different kinds?
So cancer cells have about probably 9 to, I think we have it estimated to about 11 different mechanisms for inhibiting the immune system. And they do that for a variety of reasons. Number one is so they don't get attacked. But more importantly, they hijack a lot of the resources and growth factors from the immune system. So they want to encourage the immune system to bring in its resources and its cells and cytokines, and then once they get there, they disable it.
The cancer cells do.
The cancer cells disable it, or they disable the attack component of it.
And take the food.
And take the food, yeah,
Right.
the growth factors.
So immunotherapies work how?
So what they do is there's many different ways. So the pathways we know right now, one of them is called the CTLA4 pathway. There's a drug called ipilimumab, and that's one way cancer cells inactivate the immune system. The other common one is the PD-1 axis. And so PD-1 is referred to as programmed death 1. And what that does is it's like a protective sheath that all cells have to have. It's a receptor that all cells in our body have to have. And if you don't have that receptor, you're considered a foreign invader. And so what cancer cells tend to do at various times throughout their growth is they will rapidly reproduce this PD-1 protein. So they create this bubble around the tumor. So when the immune system comes to investigate, it gets inactivated right away.
Oh, so it can't even assess for whether it should be there or not.
Exactly. It just ignores it. So PD-1 inhibitors, and this is common because you will find certain lymphocytes and immune cells within tumors. They will try to attack it, but then they just get turned off. And so PD-1 inhibitors basically act like a sponge and soak up the free PD-1 protein, so the immune system can then recognize the tumor as being not a normal function.
Okay, so immunotherapy, so targeted therapies target the mutations that are causing the cancer. Immunotherapies help your immune system to better find the cancer cells. Okay, and you said something about proton therapy. What's that?
Well, there's more on immunotherapy if you'd like to hear that.
I think the people at home would.
Well, we also have another class of drugs called IDO inhibitors, and that's just another pathway that's that the immune system uses. So we've probably got another 7 more drugs and pathways in development right now that we're working on.
Ooh.
Yeah, so then we'll have the whole, and the important thing is to understand that not every tumor is going to interact with the immune system in the same way. They're going to use different mechanisms at different times throughout the growth, in between different tumors, and in between different parts of the tumor.
And that really is why there's no one treatment for everybody.
No.
This concept we hear so often, that big pharma is hiding the cure for cancer, or that there is a cure for cancer, or that there could be a cure for cancer. And the farther we go down this rabbit hole, the more it seems like we can cure cancer, but it won't be the same cure for everyone.
Exactly.
Yeah.
Yeah, very different.
Yeah. And proton therapy?
So proton therapy uses actual protons rather than ionizing radiation. And it's an interesting approach. It requires many treatments, but there's, proton therapy centers opening up all across the U.S. and there's some in Europe and so on. And it's a way of targeting and ablating a tumor that is hard to reach surgically without getting a lot of the side effects from standard ionizing radiation. So it uses protons instead.
And the research is showing it's at least equally as effective as
it's very close. But the reduction in the side effects is really why it's used, and it's able to target tumors that are in dangerous places. So not to confuse protons with photons. Photons are from ionizing radiation, and protons are part of a atom structure.
Okay. All right. Well, that's interesting. Well, Greta, who knew that we were going to go down that rabbit hole thanks to your question, but thank you for asking about alternatives to chemotherapy there.
Thank you for watching Cetome TV. Subscribe below and stay informed.